This video is just one problem. It's how to find the second derivative using implicit differentiation, okay? How do we do that? Because I didn't do a problem like that in the initial lecture, and you do have a problem or two that pop up like this on your web assignment. So how do we find the second derivative of this right here? Well, first of all, we're going to have to do implicit differentiation. Why? Because you have y raised to some power higher than 1. How do you do that, though? Remember, we did d dx of everything, d dx of both sides. So what's the derivative of x squared with respect to x? That's just 2x to the first. What's the derivative of 3y squared with respect to x? That is where implicit differentiation comes in, right? Because you're going to have the derivative of y squared with the 3 up front. That's going to become 6y to the first. And then what else is going to pop out of it? A dy dx. And all that's equal to 0, right? Derivative constant 0. And to find the first derivative, we would solve for dy dx. So we have, 6y equals, I'm sorry, not 6y. dy dx equals negative 2x over 6y, which gives us negative x over 3y. So now we know, dy dx is equal to negative x over 3y. That's our y prime right here, right? This is y prime. So I just reduced this right here. How do we find the second derivative? Well, we have to take the derivative of this guy right here, right? So if y prime is negative x over 3y, or I'll say, hey, dy dx is equal to negative x over 3y. If I do d dx of both sides again, right, because that's what taking the derivative is with respect to x, what are we going to wind up with? How do we do that? Well, on the left-hand side, it's pretty straightforward. That's just going to be d squared y dx squared. That just means second derivative. Like if you had d cubed y dx cubed, that's third derivative with respect to x. Now, how do we derive the right-hand side? Well, this is going to be the product rule right here. You're going to have, remember the top is f and the bottom is g. So we have to do the quotient rule right there. Remember the quotient rule says, it's gf prime. So that's 3y times a negative 1 minus, remember, g times f prime minus fg prime. So f is negative x. Really important to keep those parentheses. Then we have to derive g. Remember, we're deriving everything with respect to x right here. So what's the derivative of 3y with respect to x? That is 3 and then dy dx. And all that is divided by g squared, right? Because that's what the quotient rule calls for. G squared is 3y squared, that quantity. Now, what do we do from here, right? Because you have this dy dx, and we're wondering what is that? Do we leave it like that? No, we actually have to not get rid of it, but rewrite it in terms of just x's and y's. How can we do that right there? Well, we know what dy dx is, right? What is dy dx? It's negative x over 3y. So we're going to take this and we're going to plug it right back in for dy dx right there and then simplify it. So that's how you find the second derivative, third derivative, whatever derivative. Anytime you have derivatives that pop up while you're taking, the nth derivative, meaning second, third, fourth, or whatever, you plug back in what those older, or I'll say like younger derivatives were back into that equation. Now let's see what we have, or what it all looks like. So this is all equal to, this is going to be negative 3y. This is positive 3x, because I'm going negative times negative is a positive. X times 3 is 3x. Dy dx was the negative x over 3y, right? I'm taking this, and this is dy dx, and we're plugging it into this right here. And then all divided by, and 3y squared, that quantity is 9y squared. Now we need to simplify it. Got to simplify this, right? What can we do? Well, we can definitely knock out these 3's, right? And then we have negative 3y minus x squared over y over 9y squared. Now you definitely can't leave your answer like this, right? This is a complex fraction. It just means when you have fractions over fractions over fractions, right? Like we have this little mini fraction here over this fraction. What do you do in order to get rid of the mini fractions? You multiply everything by the LCD of those mini fractions. So these are all over 1 right here. When I say mini LCD or mini fractions, I'm talking about the mini denominators. Like what's the LCD between 1, 1, and y? It's y. So what I'm going to do is I'm going to multiply everything by y over y. This is legal because this is just a fancy form of 1, okay? So we're going to have y times negative 3y, and y times this component here, and also y times that component. And again, the reason why we're doing that is because we want to get rid of these mini denominators. Why did I choose y over y? It's because that's the LCD between 1, y, and 1, okay? Now, what happens when we do that? Negative 3y times y is negative 3y squared. Negative x squared over y times y, that's just minus x squared. What happened? The y's got knocked out, right? They reduced. And then in our denominator, we got 9y cubed, just like that. And this is how you work it out. So again, you derive it, the first derivative, you find that correct using implicit differentiation. Then to find the second derivative, you're going to sit there and derive that first derivative. And there may be an instance where if you have y components left in there while you're deriving that first derivative, you're going to have a dy dx that pops out. So what do you do with those dy dx's? You substitute what the derivative was back into that equation, like what we did right here, and then we just go out there and simplify it as much as possible.